The funny thing about quotes is that they get a life of their own. I always enjoy taking quotes out of context and give them a new life, and it would appear that Steve plays the same game, in fact, much better than I do. In fact, APL has been the longest commitment in my life, possibly only slightly less long than my commitment to music, and music is probably what I would be doing if I wasn't here and I wasn't paid to do something else. But in my life I've enjoyed a lot playing with programming languages. I tried quite a few, and I think there's space for many of them, and we're gonna see some of that today. The arena, what we're going to talk about is in the context of a big program written in APL. The program is called SOFIA, like the pronunciation is the same as the name of a famous actress and also the name of my niece. It's a you shouldn't call it SOFIA because that would make it a different kind of software. It's a portfolio management system. It's one of those programs that have made APL famous and have made a lot of people rich. It doesn't seem to have quite worked for me because I wouldn't be exactly here. It's a program more than 20 years young, which means that every single day there are more or less 40 APL developers who are putting new stuff into it. It's not just maintenance, it's active development. The reasons are various. Mostly it's because our customers have whimsical ideas about what we should be doing, and they keep changing their minds. But there's also the fact that various organs of control of insurance companies. Well, it's a product for investors, but not private investors, mail insurance companies, and they are subjected to a lot of control. And every time one of the responsible for controlling that these organizations work as they should, as a new brilliant idea or a new one appears, then we need to rush and make sure that our users can comply to the requests. SOFIA is one of those programs that can produce and will happily produce loads and loads of data. And unless you're a superhuman who enjoys browsing through thousands of lines of meaningless numbers, mostly you'd like to have ways to understand what's behind the raw data in easier ways. And this over the years has been a common request from many parts of our user base, and we finally decided that it was time to put some effort into it. Now, we don't intend to compete with established reporting tools. There's quite a few that are already established and quite a few that are coming out. Our intention was to try and find areas in SOFIA that would particularly benefit from interactive analysis of data done with tailored tools, not generic tools. The reason is that you just open your web browser, point it to Google, and you search for reporting data, and you find all these very interesting claims. These claims are quotes I've taken from the web. I've just censor the name of the companies and of the products. But we don't have interest in playing the same game, mostly because that's not our core business. We don't even want to try and pretend that we're playing the same game, because otherwise the users would start comparing us with what they can find, and they would be very frustrated when they discover that we can't even match Excel's capabilities. Also, one of the things that we don't want to do is we don't want to design a generic editor for charts, and that's because designing a generic editor is hard. I hope Nicholas is not offended. I've taken the liberty of putting a few screenshots of his wonderful wizard. It's not even half of the pages, and there's a lot of stuff. And one of the problems is that something like that looks obsolete as soon as it hits the users. And it's not because the people who try to write editors like that don't try at their best and don't succeed in giving the user something that they can use. Just inherent in the problem they're trying to solve. So none of that. Plus, this is typically what happens when somebody designs a GUI, and that we don't want to get there. I mean, our application has already a bit of that problem. I mean, it's quite easy to design a slick interface when all you have is a text box and a button, but our users want a bit more than that. So what do they want? I'll try a quick demo. So there are two areas where we have started integration of fancy charts. One is in the asset liability management, and one is the risk-adjusted performance. I hardly know anything about any of these two topics, so I'm just going to pretend I know and show you what it can do. So on the top half, you see what I was mentioning. It's only 40 rows, but it could be hundreds or even thousands. And all these rows have various attributes. They are assets or meta-assets or benchmarks. And at the bottom, we see exactly the same content, but in a much more approachable way. And the idea is that you'd use the bottom half to look for interesting assets or benchmarks or whatever to look at. So for instance, you go to a 5 years, hello? Right. You go to a 5 years horizon, and you see that there are a few outliers here. So you mark them for analysis, and what's happening is that in this grid here, the system has put checkboxes, which means that these are the lines we're interested in. And so we can go now to the yield analysis and those three lines. We can look at what's behind the three lines once again. Plenty of data. In fact, each one of these three lines is backed by several historical series in addition to a lot of attributes. And we can look at the historical series of the first line we selected. Given that this has a touch interface, I can even touch. I can look at more indicators. And I can even choose if I want to compare it with other historical series I have in the system, like randomly this one. So this is one of the ways. In asset liability management instead, what we have are hundreds, thousands of scenarios which are generated with a stochastic model. And this is an overview of each one of these 1,000 scenarios where the attributes have been put on axes and one continuous line represents one of these scenarios. So for instance, if I want to concentrate on the scenarios where the premium is above 78.5 million, I just drag and select, and these are the 6 lines. If I want to, I can filter some more of these axes, and I have identified one line. Now this is ugly and it'll get better in the future. I can look at the details of this scenario. Once again, pages and pages and pages of numbers. Numbers, more numbers, numbers, plenty of numbers. And at the very end, a few graphs which help understanding. So, you can look at this, for instance. And we can concentrate on just a part of the timeline and scroll within the timeline and switch on and off contributors to the totals and so on. We can choose to see them grouped, and if we want, we can also produce a PDF file. So, how did we get here? I have a lot of material, really. It's 45 slides, and it's impossible to concentrate on each one of them in detail. So what I'm going to do is rush through the content of the presentation. And if you see anything that particularly tickles your fancy, you can ask me later, and we can concentrate on the aspect I've just glossed over. Otherwise, we'll be done earlier, hopefully, and Andy will be pleased. When we had to look for a tool to put in practice our vision on what we wanted, what one does is Google for stuff, and the D3.js kept coming on queries using very different kind of keywords. So I got interested, and it turns out that D3 actually matches the philosophy of APL in the sense that it's a tool and it's not a finished product. And its main focus is on data. It's not on the way things should look. It's a way to make things look the way you want, but starting from the data. So we thought, well, and it's also got a very nice set of quite astonishing examples with the exact wow factor, which helps selling just about anything. So after a short while, we decided that D3 was probably our target. And D3 being a web-based technology, means that we needed to find a way to integrate it in SOFIA. Now, a framework instead of a library means that we have to work more, but we know that we're not limited by what the authors of the library have conceived. We knew we could do just about anything we wanted. It's also supported by a really friendly community. The original author is a guy called Mike Bostock. He was a data scientist for the New York Times, and he's now gone solo. and continues to develop D3 and probably does consultancy. And it's open source software. Open source software is a bit of a red herring in the sense that it helps, but it's not required in a commercial environment. Linux is open source, yes. At the latest count, the Linux kernel contains 50 million of lines of code. Now, yes, it's open source, and yes, it's completely useless to me. D3 is small enough that one can actually read the code, not in a lifetime of efforts, but in a day, which means that even just trying to understand how it does certain things can be achieved. Also, D3 is a very liberal license, which means that it can be used anywhere, which is a good license, but once again, had it had a more restrictive license, not in the sense of open source, but in the sense that for commercial usage, it required special considerations, it wouldn't have bothered us much. So how do we go about embedding something that is based on web technology into a product like SOFIA that is a Windows GUI application with its own GUI framework? Well, we need a web server, we need a web client, both embeddable, and we need some glue. For the glue, we decided to go with .NET. The support in Dyalog APL is really quite good, almost always. I've tried COM, it was fun, but enough for a lifetime. And .NET really provides, in my opinion, a huge productivity boost. The community is immense. C# is really quite a nice language, in my opinion. It's got garbage collection, which you'll love, and there's Visual Studio. Now, I know real men love their command prompts. I know real men don't use mice. They don't use GUI interfaces. They like their VI editors. Well, I'm not a real man. I'm just a software developer. So I really enjoy using Visual Studio. Yes, web server. People might think that I'm obsessed with web servers. This is the third time at an APL meeting that I talk about the web server. The web server we're going to talk about is not written in APL, and I did not write it. One of the servers I wrote and presented is the one behind my server. Not this time. There are various reasons that we don't have really the time to go into them. But, sorry, the one we chose is called NoWin, and it's a double pan. It's a server that would work also outside Windows, which means that it doesn't rely on kernel components, only raw TCP sockets. And it implements OWIN, which is an acronym for Open Web Interface for .NET. It defines a standard interface between .NET web servers and web applications. The goal of the OWIN interface is to decouple server and application. It's to encourage the development of simple modules for .NET web development. And by being an open standard, it is open. It stimulates the open source ecosystem of .NET web development tools. This is what OWIN is really all about. They introduced the concept of a middleware, which is really a fancy way of calling a component, which calls into another component, which calls into another component. And once we get to the bottom, we go back up the call stack, and more logic can be applied so that the request is processed and the response is processed by various layers. This is quite nice because it helps dividing the concerns of the application into cleanly separate modules. This middleware 1 could have been logging. This middleware 2 could have been authentication, and there could have been one for authorization. Then one can plug different MVC frameworks to actually generate the content. And one can also plug modules to handle static resources, where by static resources I mean HTML images and style files that don't need to be dynamically generated. Static resources means that they must come from somewhere, and normally they come from a file system. What is quite interesting, and what I find extremely useful, is the introduction of a virtual file system, and this standardization was done by Microsoft. Where one defines a few methods and a few properties on a few objects, which describe the essence of a file system, and then there can be several different possible implementations. Starting from a real file system, I mean really a share or a directory on an NTFS formatted drive, to the most extreme, an in-memory zip blob. I mean, a zip file in itself is a file system. And if we take the bytes and put them in a workspace, those are as valid as a file system, as a real file system. And we're not going to deal with this because we don't really have time. But you probably understand what I talk about. SOFIA is built over in-house a source code management system, which is based on component files, and we're quite good at shipping patches to the code as long as it's in the repository. Now, HTML files outside the repository would give us trouble, so we'd rather have stuff that it's in the code repository. So we did the development of our web app using physical file systems, and just before shipping, we just zip it all, put it in a blob, and put it in the code repository, and that gets shipped. And we can easily have the web server target both aspects. For the client, no Chromium, no Gecko, too many limitations. They would have been better, so we went for Internet Explorer. Even Internet Explorer gave us a choice, and eventually we went for the OCX, which forced us to have a backend server. Hopefully, Dyalog will solve the problem for us in the future. What are we shipping? Windows XP is dead. Good riddance. I'm not one of those who thinks that XP was the best version of Windows ever, and I upgraded to Windows 10 as soon as I could. I've also updated to Windows 8.1 as soon as I could, and I think everybody should do the same. There's really no use in staying with Windows XP, which has now become a problem because Microsoft has stopped support in 2014, which means that if you rely on Windows XP, your customers are opened to all the security bugs that were reported and will never be fixed. So, Internet Explorer 11, it's not the best, but it's decent. It supports web standards reasonably well. So what's inside? What have you looked at? SOFIA is really a bunch of functions in an APL workspace. And what we have is a tiny instance of a web server written in C#, which is loaded into the workspace using the .NET Bridge. And in SOFIA there are GUI forms, which are also in the workspace, and there's Internet Explorer as an OCX instance, which contains DOM objects, document object, model objects, both HTML and SVG, and some JavaScript. All of the animations and so on you've seen were featured by D3, which is in here. So one thing, we just point the OCX to a URL and Internet Explorer just acts as it should normally, gets the web files. If the web application wants to talk to the workspace, which is, if something happens here, which needs to be reflected here, it can make a GET request or a POST request to the web server, and the web server has callbacks which can be fired and execute APL functions, so complete freedom. If APL wants to talk instead to the web application running in here, then what we do, like if the user clicks on this button do and wants something to happen here, like when I clicked on the 5-year radio button to extend the range, that was a GUI that was outside the web application. We just inject JavaScript code using the eval method of the OCX. And it can be anything. It can be as innocuous as a global variable assignment in the JS engine. It can be a subroutine call, a function call, anything. This is too complex. How are we doing with time? 15 minutes left, okay. So we'll skip this, and we can go back if you think it's interesting. To do the printing, we actually involve another product which is called Phantom.js. It's normally used to do testing of web interfaces. Because what it is, it's a web browser without a GUI. It's just WebKit, which was one of the, it's still one of the major browser engines around. It's the engine behind Safari, and was the engine behind Chrome before Google decided to fork it. Now they're living different lives. Phantom.js is programmed in JavaScript, and one can write a little piece of code which connects its internal web engine to the web application that lives in here, and get a clone of what was in the window. And one of the features of Phantom.js is the capability of rasterizing the content, not to put it in a GUI, but either to put it in a bitmap that can be saved on disk, or in a PDF file. And it's quite nice that Phantom.js actually goes to the trouble of trying to keep what is vectorial as vectors in PDF, so it doesn't rasterize what can be kept vectorial, which means that users get better fidelity and they can print in higher resolution. Since JavaScript keeps coming up, I thought I'd spend a couple of words on what JavaScript is. The history is quite interesting. Netscape in 1995 asked this fellow, Brendan A., to implement a language that was supposed to have was supposed to be a sort of scheme into their Netscape navigator. Later, they decided that the syntax of scheme would not be liked. That was probably a mistake. And they went for a syntax that looked closer to Java, which was another mistake. And what happened was that there was obviously internal mayhem, and the group that was supporting this idea had to present a working prototype, so they asked A to produce one, and he did, in 10 days, which means that JavaScript is almost a miracle, because what Brendan spec'd and implemented in 10 days pretty much remained what then JavaScript was released with. It has a few mistakes, but considering the time it took, it's almost a miracle. It was originally called Mocha, and only later they made the third mistake by calling it JavaScript. They caused a continuous source of confusion. Most people think that JavaScript and Java are related, and they are not. They share bits of the external syntax, and that's it. We could call it ACMA script, which is the modern name since a standard committee has taken over its steering. But people tend to refer to it as JavaScript anyway. As I say, it's a nice language. No, really, it is a nice language. It's much closer to Scheme than it is to Java. And it proved to be relatively straightforward to adopt in a shop where everybody's an APL developer and not a computer scientist. It shares some basic ideas with APL, and it permits developers to do horrible things, which I wish they did not. But since they do it in APL anyway. And the web is full of resources to learn and solve problems. In order to put this all together, my colleagues had to learn HTML, CSS, JavaScript, and D3.js, and a bit of other libraries, and to use external tools. I mean, they were using the Dyalog APL session, so they had to learn to play with external editors. I recommended Visual Studio, but everybody could do whatever they wanted. We decided that we would base source code management of the JavaScript bits on GitHub, so they had to learn a bit of Git. And it didn't take them long, really. The release cycle at the time was less than 6 months, and in 6 months they wrote the code, and pretty much what you've seen in the demo was produced in 6 months. It's under active development, but I consider it quite a success, because I had a head start, and despite the fact I hardly mentored any of them. This slide summarizes a bit my reference to freedom in the title. We kept all the doors open to do what we wanted with as much freedom as possible. Where we go in, I think the most important it's this. If Dyalog does what they seem to be doing, then we could get rid of most of what we've done in terms of integration of horrible external components, which would gain us a linear application and more conformant to standard, because since they work on Chromium, we would gain 4 years more of development in web engines. Microsoft Edge is a nice temptation, but we can't, because Microsoft at the moment has no intention of making Microsoft Edge an embeddable component, which is definitely a no-go. We want something that it's inside SOFIA. And in SOFIA, obviously, those 2 charts, well, 3 charts you've seen are just the beginning, and they need improvement, and we have ideas on other areas. So, are there any questions?
So there are libraries out there like Node.js which allow you to create applications just from HTML and
Yes.
JavaScript. I was just curious as to why you took the approach of embedding the browser rather than building it kind of the Node.js approach and only farming out the request to APL.
Well, that's because SOFIA at the moment is probably more than 200,000 lines of APL, and we cannot rewrite it in JavaScript.
Yeah.
So, you must remember that it's SOFIA that generates the data. Most of the data is generated when I click on buttons, which means that for our developers, they are the domain experts. It's much easier to write APL and then learn how to create a CSV file, well, a CSV representation or a JSON representation of the data and ship it over to a JavaScript front end, then to have to save the file somewhere and fire an external application. Too many moving parts. Also, normally SOFIA is installed in large corporations where it's deployed on Citrix servers. So we don't want to have millions of processes being spawned for each client, because there are already many clients running on the same box. So I don't know if that answers your question.
Yeah, answers the question. So if you was to do it again from scratch, you would still do it the same way?
Yes. This we would do the same way. If we had dialogues, obviously we wouldn't have to have a web server which communicates with APL. It would be much more compact. And if you want, also the issue of the virtual file system would disappear, because in a sense there would only be requests, and we would reinvent the wheel if you want. But this experience teaches us a way of structuring an application which I quite like. The idea of having a multi-layered application is really quite nice, and it's a good mental exercise to try and divide the application. I mean, the very small part of the application, that it's the charting bit, into separate modules which can then be reused. One of the things I've only touched here is this. This is an interesting trick. Microsoft, in their infinite wisdom, decided that the embedded version of Internet Explorer would default to the full compatibility mode, which is, I don't remember if it's IE6 or IE8. Anyway, 10 years old technology at the best. And D3 simply does not load in that mode. One way to do it is to put an HTTP header in every response, and this header with a certain setting forces Internet Explorer to forget compatibility mode and go into nowadays mode. That is simply a middleware layer in this stack. Yeah. So one of these simply injects the header on the way back. And another way to obtain the same result is by putting into the header of the HTML file that same tag with a different syntax. But obviously this means that every single HTML page that my colleague have to produce must contain that header. And I thought it would be much easier just simply to hide the complexity and have the server deal with it. But by having it as a separate module, in a sense, it's pluggable, it can be added, it can be removed. I really like that way of thinking.
Thank you.
Okay. First of all, I think I'd like to congratulate you on this, because I'd heard a bit about this project and it sounded unnecessarily complicated to me.
Yes.
But after seeing the demo, I know a little bit about SOFIA from history, and it really looks like a natural extension to the rest of your user interface, that you've managed to add this graphical component that allows people to sort of, in the same way of thinking about formulating queries, is extended graphically. So that's really good. I think you answered my question, the question I had, which I was a little bit confused because very early on you rejected Chromium as a solution, but maybe that was just because of how you would have to embed it.
Where's the slide? No. Anyway.
Because Chromium. So what are you going to get from us?
No, Chromium is exactly what we want to use. Chromium itself is a problem because, first of all, in its default form, it's a huge runtime. It's a couple of 100 megabytes on disk, and SOFIA is much smaller than that.
Right. Yeah. I mean the zero footprint UI.
Exactly. And second problem, Chromium doesn't have a COM interface, and it's got a non-official .NET wrapper. And non-official is quite fundamental in all of this, which means that it's reliable, but it's very edgy. Okay. So the day we have your version, it's going to be exactly what we want.
Good. Well, we will redouble our efforts. We're still looking at whether we can embed it in QuadWC GUI, so you could just have it as a...
Well, if you can't, then we won't use it. So it's not a real problem.
No, it's very simple. I'm impressed. Your colleagues learned all that stuff in 6 months. I just wanted to know how long they have been studying APL. How long it requires to them to learn the APL they use for everything else?
I have no idea, but probably 3 weeks.
3 weeks. Okay.
Yes. If we want to be honest, during those 6 months, they did another 25 projects. This one was the low priority one, despite being on the schedule for a major release. So it's a bit unfair to say that they spend much more time learning this than anything else. Anyway, thank you.
Okay, thank you very much.